Since as early as the 1970s, humans have been sending rovers to explore the mysterious terrain of our neighboring planet, Mars. With each rover steadily increasing our understanding of the Red Planet, from exploring the geology and climate of this world to seeking signs of past life. Today there have been over 6 rovers that have touched and explored the surface of Mars. But what about our much closer and easier to get to celestial body, the Moon? Quite surprisingly, there have been fewer rover missions to the Moon as compared to Mars, with only 4 lunar rovers ever touching down on its surface. Why is this? Well, one of the reasons for this is that the Moon is rather boring compared to the Martian planet. We kind of know how it formed, what we can expect to be hidden under its surface, and if it can support life or not. However, recently, NASA has discovered an exciting new purpose for the Moon. It could be a launching site for future missions to Mars. Why? Because the Moon has less gravity and no atmosphere, which means it could save NASA money and fuel for future Mars trips. By setting up a base or station on the Moon, astronauts could do research, test new technologies, and learn how to live in space for long periods of time before they head off to Mars. In preparation for such a future, NASA has unveiled their newest lunar rover. Named VIPER, Volatiles, Investigating Polar Exploration Rover. This rover will land near the lunar South Pole in late 2024 in search for water ice and other resources which will eventually be harvested to sustain human exploration on the Moon and Mars and maybe even beyond. VIPER will spend 100 days roaming the lunar South Pole region, collecting data that will reveal where water ice is most likely to dwell and determining how easy these resources will be to access. In the process, VIPER will become the first ever resource mapping mission on another body in the solar system. These resource maps will be a vital step in establishing a long-term human presence on the Moon. Collecting data regarding water on the Moon is not a new occurrence. In fact, Moon-orbiting satellite missions have been doing this for years. However, VIPER will be the first to get up close and personal with the lunar surface, scanning with its scientific tools and investigating soil at varying depths with its 3.3-foot or 1-meter-long drill. Also equipped is a neutron spectrometer system to sniff out hydrogen levels and a near-infrared volatile spectrometer system with a mass spectrometer to back it up. This way, the rover should be able to find large concentrations of hydrogen before even drilling, and then analyze those samples without needing to send them back to Earth. Some of the regions VIPER will explore are permanently shadowed craters that are some of the coldest places in the solar system. Due to the fact that no sunlight has ever reached them, it is believed that the bottoms of these craters harbor ice that has been undisturbed for billions of years. As it conducts its mission, VIPER will be exposed to the extreme environment of the Moon, the ultra-fine dust coating its surface, the harsh UV rays from the sun, and the incredibly cold temperatures of these permanently shadowed areas, all while having to overcome the bumpy and unforgiving terrain of the lunar surface. Therefore, testing of VIPER's systems is of utmost importance to the success of the mission. As the NASA engineers assemble and install various subsystems onto the rover, they perform channelization tests. Their tests involve sending commands to specific instruments or subsystems to check if they respond correctly and if data is transmitted accurately, enabling the team to confirm that pieces and parts like cable harnesses and connectors between systems are working. However, testing for resources is only part of its primary mission, and VIPER has another important trick up its sleeve. It's going to be able to operate during lunar night. This may seem like a fairly insignificant task on the surface, however, as previously mentioned, the Moon lacks an atmosphere. And because of this experiences wild temperature swings as it rotates into and out of the sunlight. In this unforgiving lunar environment, temperatures fluctuate dramatically between scorching highs of 120 degrees Celsius during the day and bone-chilling lows of negative 130 degrees Celsius at night. These extreme conditions, with each phase lasting roughly 14 Earth days, pose a formidable challenge to spacecraft and rovers, threatening to completely freeze or overheat most electronics and mechanical parts. This is why other lunar robots like the Chinese U-2 rovers typically shut down during the night to preserve power in the hopes of reactivating during the next day's cycle to continue working or just opting to work as long as possible before dying, like India's Chandrayaan-3 lander, which recently ended its mission when it failed to wake up after its first night on the lunar surface back in September. Keeping a rover operating through this sort of intense cold would be very useful, as it would allow us to study phenomena on the moon and other extremely cold bodies that we haven't been able to yet, like the electrostatic current that scientists believe forms on the lunar surface at dawn and dusk, which could cause a thin layer of dust to levitate briefly. As we look ahead, we are reminded of the challenges that lie ahead. Yet with each test, each setback, we inch closer to our ultimate goal, a sustainable human presence on the moon and beyond. As VIPER embarks on its historic mission, we stand in awe of the possibilities that await us. From the frozen landscapes of the lunar South Pole to the vast expanse of the Martian horizon, the future of space exploration shines brighter than ever before.